Hello viewers, in last video we have discussed about the angles and their measurement, that is degree and radian measurement of trigonometry and the relation. In today's video we will discuss about trigonometric ratios and some identities. So there are how many ratios? There are 6 ratios: sine, cosine, tangent, cotangent, secant and cosecant. We know for a triangle ABC, in a right angle triangle ABC, this is your perpendicular, this is your base, this is your height, this is your angle theta. So we know what is sine theta. Sine of theta is equal to P by H. Cos of theta is equal to B by H. Tan theta is equal to P by B. If you know sine, cos and tan, you can easily find cosine, sec and cot, because cosine is the reciprocal of sine, sec is the reciprocal of cos and cot is the reciprocal of tan. So if you know these 3 relations, you can easily find their reciprocals, that is cosine, sec and cot. Now today we will discuss about the real definition of trigonometric ratios. We call it real definition. Real definition. This is your circle. This is XY plane. If I draw a circle with origin as center and radius R, now this point will be r, 0 on the x-axis. This point will be 0, r. This point will be minus r, 0, and this point will be 0 minus r. So let capital P x, y be any point on the circle having radius small r. That is, if I join this origin and the point P, then OP is equal to small r, and the point P has the coordinates x and y, where x coordinate is x and y coordinate is y. So it will be like this. This is x, this is y. So it forms a right angle triangle. So the real definition is, for the angle theta, if the angle POX is equal to theta, then sine theta is equivalent to the y coordinate of point P divided by the radius of the circle. That is, for this point P, the y coordinate is small y, so it will be y by r, and cos theta is equal to x coordinate of point P by the radius, that is x by small r. Now what is tan theta? Tan theta will be is equal to y coordinate of point P divided by x coordinate of point P, that is, it will be is equal to y by x. So if you know sine, cos and tan, we can easily find their reciprocals like cosine, sec and your cot. Okay, this is the real definition. When the point P lies in first quadrant, that is, in the first quadrant, now there are how many quadrants? 4 quadrants. First quadrant, second quadrant, third quadrant and your fourth quadrant. You can easily say, in the first quadrant, x and y all are positive. So I can write x greater than 0, y greater than 0. In the first quadrant, x and y both are positive, and the radius r, obviously this radius which will be always positive. So that's why the value of sine theta and cos theta will be is equal to positive, because y and x are positive in the first quadrant, that's why the values of sine theta and cos theta will be positive as r is positive. Similarly, x and y both are positive, the ratio of this will be always positive. That means in the first quadrant x positive, y positive. So your sine theta is positive. Now if the point P moves through some angle and it reaches second quadrant, the second quadrant we know x negative and y positive. In second quadrant your angle theta, for angle theta, the point P reaches here, this is P dash, then what will happen? This angle theta, for the angle theta, if I find the sine, the value will be positive because here x is negative but y is positive. In second quadrant x is negative but y is positive. So I can write in second quadrant your sine x is negative whereas y is positive. That's why sine theta will be positive. Okay. For cos theta is positive in first quadrant, but in second quadrant it is negative because for the point P dash, here the x coordinate of the point P dash will be negative. So your cos theta will be negative. Here x is negative. So in second quadrant cos is negative. And for tan theta, in first quadrant tan theta is positive as x, y both are positive. In second quadrant x is negative, y is positive. That's why the ratio of y and x will be negative as they are of different sign. So in second quadrant tan is negative. In third quadrant that is here x is negative, y is negative. So x and y both are negative. In this quadrant the sine theta will be negative as y negative, cos theta will be negative, but the ratio y by x is positive as both are negative. So I can say that in third quadrant x is negative, y is negative, that's why sine theta is negative, cos theta is negative, whereas tan theta is positive. And in fourth quadrant here x is positive but y is negative. So x is positive and y negative. So we can say that sine theta will be negative, cos theta will be positive, and the ratio of y by x will be negative as they are of opposite sign. So I can say that here x is positive, y is negative. So sine theta is negative, cos theta is positive, but tan theta is negative. So if you know the signs of sine, cos and tan, you can easily find the signs of cosine, sec and cot. Since in first quadrant sine theta positive, it implies cosec theta also positive, cos theta positive, sec theta positive, tan theta positive, that's why cot theta positive. That means in first quadrant all the ratios are positive. That means when the angle theta will lie between 0 to 90 degree, in first quadrant the angle, for the angles theta, the value of all the ratios sine, cos, tan, cot, sec, cosec will be always positive. In second quadrant when the angle reaches in second quadrant, that is between 90 and 180, then the value of sine theta is positive. That means cosec theta is positive, cos theta is negative, that means sec theta negative, and tan theta negative, that means cot theta also negative. In third quadrant sine negative, cos negative and cot tan positive. That's why for tan positive we can say cot positive. Since sine negative we can say cos sec negative, and since sec cos negative, that's why sec negative. And in fourth quadrant your sine is negative, that means cosec negative. In cos positive, that's why sec positive, and tan negative, that's why cot negative. So you can define a relation. This is called ASTC. This is called ASTC. That means in first quadrant, this is number 1, this is number 2, this is number 3, this is number 4. In first quadrant all the ratios are positive. In second quadrant only sine positive. If sine is positive, that means cosec is also positive. In third quadrant tan positive, that means cot is also positive. And in fourth quadrant the cos is positive, that means sec is also positive. This is called ASTC rule. We call it ASTC rule. Using this we can easily say in which quadrant the value of which ratio will be positive or negative. This is your ASTC rule. Now we will discuss about different reduction formula. Different reduction formula. We know for theta be acute angle, it lies in first quadrant. This is your x axis, this is your y axis, this is your x dash, negative side of x axis, this is your y dash. Now for theta being an acute angle, this is px comma y. For theta being acute angle, we can say your sine theta is equal to y by r being the radius, cos theta will be is equal to x by r, and tan theta is equal to y by x. Now this is called reduction of number 1, reduction of 90 degree minus theta, 90 degree minus theta. Now how to reduce this? We can write sine of 90 degree minus theta is equal to cos theta, cos of 90 degree minus theta is equal to sine theta, tan of 90 degree minus theta is equal to cot theta. But how? So we will use geometry to prove this. Let this is your xy plane, this is your circle with radius r. Let this is a triangle. This angle is 90 degree minus theta. This is right angle. This angle must be theta, because we know sum of three angles in a triangle will be is equal to 180 degree. So if it is 90 degree, this is theta, this is 90 minus theta. If I find their sum, it will be is equal to 180 degree. And for this triangle, this is theta, this is perpendicular, this is 90 minus theta. Okay. Now these two triangles are congruence by the congruency of RHS. This is right hand side congruency. Now this is your right angle triangle having hypotenuse small r, and they have similar angles. So for this triangle, the length of the side corresponding the angle theta, that is the opposite angle of theta, is equal to y, and for the angle 90 minus theta, the opposite side is of length small x. And for this, since they are congruence, that means for the angle theta, the opposite side will be of length y, and for the angle 90 minus theta, the opposite side will be of length x. Therefore I can find its point P dash coordinates as y comma x. Now I have moved from the origin along the x direction y units, along the y direction it is x units. When theta is acute, 90 minus theta will be also acute. So the point P dash y comma x is lying in the first quadrant. Now if I find the ratios for the angle 90 minus theta, I will get sine of 90 degree minus theta is equal to, for this point the y coordinate is equal to x. So I will write x by r. Now what is x by r? From this figure we know x by r is equal to cos theta. Therefore sine 90 minus theta is equal to cos theta. What is cos 90 minus theta? For this point P, the x coordinate is equal to y. So it will be y by small r. What is y by r? Y by r is equal to sine theta from this figure. So it will be is equal to sine theta. And for tan 90 minus theta, it is equal to the ratio of y coordinate divided by the x coordinate. For this point P1, P dash, the x coordinate is y and the y coordinate is x. So it will be is equal to x by y. Now from this figure, what is your tan theta is equal to y by x. So what is cot theta? We can write cot theta is the reciprocal of tan, so it must be is equal to x by y. So I can write this equal to cot theta. This is the reduction formula of 90 minus theta. So this is 90 minus theta reduction. Now we will reduce reduction of 90 plus theta. 90 plus theta, we can write sine 90 plus theta is equal to plus cos theta. Cos 90 plus theta is equal to minus sine theta, and tan 90 plus theta is equal to minus cot theta. As I already said, in second quadrant cos is negative, tan is negative, sine is positive. Now the angle is 90 plus theta, 90 degree plus some acute angle. So it reaches in second quadrant. In second quadrant sine theta is positive, cos theta is negative, and tan theta is negative. We know for acute angles sine, cos, tan all are positive. So sine theta is positive here, multiplied by negative sine, so it gives a negative value. Now the angle reaches your second quadrant. That means if I draw this figure, this is your xy plane. Now if I draw a circle of radius r, it looks like a circle, okay. This is your radius r, origin at center at O, origin. Now the point P reaches somewhere in the second quadrant. If I join them, center and the point P, this angle is your 90 degree plus theta. Why this is 90 degree? This is your theta. So this angle is 90 degree minus theta, because this is the one straight angle. So if I find their sum, 90 degree plus theta plus 90 degree minus theta will be equal to 180 degree. So this is x axis, this is y axis, this is x dash. Now if I draw perpendicular from the point P on the x axis, it forms a right angle triangle where this angle is theta. Now these two triangles are congruent as they have same hypotenuse, smaller, and similar angles theta and 90 minus theta. For the triangle this, the side opposite of angle theta is equal to y. Similarly for the triangle this, the side opposite to angle theta will be is equal to y, and for the angle 90 minus theta will be is equal to x, as it is 90 minus theta opposite to angle side will be is equal to x. So I can find the point P dash having coordinates minus y comma x. Why minus y comma x? Because on the negative side of x axis your x is negative. So here from the origin we are going y units toward the negative side. So minus y and x units toward the positive side of y axis. So the point P dash will be is equal to minus y comma x. Now if I use the real definition of trigonometric ratios, I can find sine 90 degree plus theta for the point P dash will be is equal to x by r, the ratio of y coordinate of the point P dash by the radius. X by r is equal to cos theta from this figure, and for cos 90 plus theta the x coordinate is minus y by r. What is y by r? Y by r is equal to sine theta, so it becomes minus sine theta. And what is your tan 90 plus theta? It is equal to minus x by y, the ratio of y coordinate by x coordinate. So minus x by y. So what is minus x by y? Is equal to minus of cot theta. So I have reduced the angle 90 plus theta. Similarly, we can reduce the angle, this number 3, it will be 180 degree minus theta. So I will not show all the reduction. I will just write the formulae, and you can learn these things from any other book or any other materials. So to reduce the angle 180 degree minus theta, we can write sine of 180 degree minus theta is equal to sine theta, cos of 180 degree minus theta is equal to minus cos theta. See, in second quadrant cos is negative, so it is minus cos theta. When I subtract theta from 180 degree, it will be an obtuse angle in second quadrant. And for tan 180 degree minus theta is equal to minus of tan theta. Similarly, number 4 will be reduction of 180 degree plus theta. Sine 180 degree plus theta is equal to minus sine theta. Now this is 180 degree plus theta. Now the angle reaches to third quadrant. In third quadrant tan is negative, so it is a minus sine. Cos of 180 degree plus theta is equal to minus cos theta. In third quadrant cos is also negative, okay, and your tan of 180 degree plus theta is equal to tan theta. In third quadrant I already said tan is positive, so it is positive sign. You can deduce this reduction by this method. Number 5, reduction of 270 degree minus theta. You can write sine 270 degree minus theta is equal to minus cos theta. In third quadrant sine is negative, so it is minus cos theta. Cos 270 degree minus theta is equal to minus sine theta. In third quadrant again cos is negative, and tan 270 degree minus theta is equal to cot theta. When I subtract angle theta from 270 degree, then the angle remains in the third quadrant. So in third quadrant sine negative, cos negative, and tan is positive. Now set 6, reduction of 270 degree plus theta. Sine of 270 degree plus theta is equal to, now 270 degree plus theta. Now if I add theta with 270 degree, it reaches your fourth quadrant. It will be in between 270 and 360 degree. So it will be in fourth quadrant. In fourth quadrant sine is negative, it is minus of cos theta. Cos of 270 degree plus theta. In fourth quadrant cos is positive, so it will be plus sine theta, and tan of 270 degree plus theta, it is minus cot theta. In fourth quadrant your tan is negative. And last is number 7, it is called reduction of 360 degree minus theta. Now what is sine 360 degree minus theta? When I subtract an acute angle from 360 degree, then the angle remains in fourth quadrant. In fourth quadrant, sine is negative, so it will be minus of sine theta. For cos 360 degree minus theta, it is cos theta. In fourth quadrant, cos is positive, and for tan 360 degree minus theta, it is minus tan theta. So we can reduce into equitangles for large angles. Okay, so this is called reduction formula of trigonometric ratios. Now we will learn different formulas of compound angles, multiple angles and submultiple angles. Now before starting the formulas of compound angles, multiple angles, submultiple angle, and we have to learn the special cases of trigonometric ratios or trigonometric functions. Now suppose this is your xy plane and this is a circle having radius 1, circle having radius 1. This is your center at the origin. Now this is your 1, 0, this is 0, 1, minus 1, 0, and this is 0, minus 1. Now here for this angle theta, this point is P x, y, we can say your sine theta is equal to y by 1 and cos theta is equal to x by 1. So clearly you can say that x equal to cos theta and y is equal to sine theta. That means any point lying on the circumference of this circle represents the values of cos theta and sine theta for the respecting angle it forms with the line drawn by the center with the x-axis. So any point lying on this circle represents the trigonometric ratios of that corresponding angle theta, which the line OP forms with the x-axis. Now this is your 1, 0. Now 1, 0 corresponds the angle cos 0 and sine 0. See here the angle formed by the OX with the x-axis is 0 degree or 0 radian. Now we will convert degree into radians, otherwise it will be to look not good. So now from degree measures we will convert into radians. Here this is 0 radian, this is pi by 2 radian, that is 90 degree, this is pi radian, this is 3 pi by 2 radian, and now if I reach again this point, it will be twice pi radian. Again if I move further and I reach this point, it will be 5 pi by 2. Now if I reach further, I will reach this point, it will be thrice pi. Again I reach here, it will be 7 pi by 2, and so on. These angles are, at this point the angles will be 0, twice pi, 4 pi, etc. At this point the angles will be pi by 2, 5 pi by 2, 9 pi by 2, etc. At this point the angles will be pi, 3 pi, 5 pi, etc. And this point the angles will be 3 pi by 2, 7 pi by 2. See, after every twice pi radian the angle repeats. This is 3 pi by 2, this is 7 pi by 2, their difference is twice pi. This is pi by 2, this is 5 pi by 2, their difference is again twice pi. This is 0, this is twice pi, the difference is twice pi. This is pi, this is 3 pi, the difference is twice pi. Okay, now sine theta is 0. Sine theta is 0. The value of sine theta is 0 at these points. When the point P reaches these two spots, the value of sine will be 0. Here cos 0 is equal to 1, sine 0 is 0. Here cos pi is equal to minus 1 and sine pi is equal to 0. So your sine theta will be 0 when theta will be is equal to n pi. N pi means integral multiple of pi, and cos theta will be 0. At this point cos theta will be 0. That is cos pi by 2 is 0, cos 3 pi by 2 is 0. So cos is 0, at this point. This is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. So I can say that it is the odd multiple of pi by 2. So cos theta will be 0 at when theta is equal to twice n plus 1 into pi by 2. We call it odd multiple of pi by 2. Next, sin theta is equal to 1. Sin theta attains the value 1. Sin theta is equal to 1 when the angle is equal to pi by 2 or 5 pi by 2. Here the coordinate 0, 1 represents the values of cos pi by 2 and sin pi by 2. Similarly, cos 5 pi by 2 and sin 5 pi by 2. At this point the value of sine is always equal to 1. So sin theta is equal to 1 when the angle theta will be is equal to 4n plus 1 pi by 2. I can represent these angles pi by 2, 5 pi by 2 like this. When n is equal to 0, this will represent pi by 2. For n equal to 1, it will represent 4 into 1 plus 1, 5 pi by 2, where n belongs to your z integer. If n is negative, then the point theta will go, then we will calculate the angle in clockwise direction. So angle will be negative. Now your sin theta is equal to minus 1. At this point 0, 1, it represents the value of cos 3 pi by 2 and sin 3 pi by 2. Similarly, cos 7 pi by 2 and sin 7 pi by 2. So the coordinate 0, 1 represents the value of cos and sin for these angles. So here the value of sin is always equal to minus 1. So cos sin theta will be equal to minus 1 when theta is equal to 4n minus 1 into pi by 2. For n equal to 0, it will be minus pi by 2. So the negative angle from this initial side, if I measured in clockwise direction, the angle will be minus pi by 2. For n equal to 1, it will 4 into 1 minus 1, 3 pi by 2. It revolves round and it attains the angle 3 pi by 2. For n equal to, it will be 7 pi by 2. Therefore n belongs to z. Now cos theta is equal to 1. Cos theta attains the value 1 at this point. At this point the value of cos will be always equal to 1. So your theta will be is equal to 2n pi. Here the value of the angle will be is equal to either 0, twice pi, 4 pi, 6 pi, etc. That is the even multiple of pi. You can write it is at even multiple of pi. Now what is cos theta is equal to minus 1? The value of cos theta will be is equal to minus 1 at this points. At this point pi, 3 pi, 5 pi, the value of cos will be is equal to minus 1 always. So I can write theta is equal to twice n plus 1 into pi. That is the odd multiple of pi. The odd multiple of pi. So using this unit circle, we can find the values of the sin theta and cos theta for some special angles easily. Now if you ask me to find the value of cos 45 degree and sin 45 degree using this unit circle, how will I find it? So to calculate cos 45 degree and sin 45 degree. Now we know this angle is 90 degree. If I bisect the angle by a straight line like this, then this will be my 45 degree. If I draw a perpendicular from this point on the x-axis, then it is a right angle triangle. This is 90 degree, this is 45 degree, therefore it must be is equal to 45 degree. So if I can find the coordinates of the point P, then it will represent the values of cos 45 degree and sin 45 degree. Now they are equal, as the angles 45 degree are equal, so the triangle will be an isosceles triangle. So if I name it as M, so your OM will be is equal to PM. Now if I use Pythagoras theorem, I can write OP square is equal to OM square plus PM square. Now what is your OP? OP is equal to 1, as it is a circle of radius 1. So OP will be is equal to 1, and OM and ON and PM are equal. So it will be twice PM square is equal to 1. It means PM square must be is equal to 1 by 2. It implies value of PM is equal to plus minus 1 by root 2. Now in first quadrant, the coordinate of point P will be always positive. It is x and y must be positive. Therefore point P will have coordinate OM comma PM, that is it will be 1 by root 2 comma 1 by root 2. Therefore the value of cos 45 degree will be is equal to 1 by root 2 and sin 45 degree is equal to 1 by root 2. That means using coordinate geometry we can find the values of special angles for trigonometric functions. So we have already learned the definition of trigonometric ratios as the coordinates of a point lying on a circle having radius r. Okay, so now we will discuss about the formulae of compound angles, multiple angles and submultiple angles. So your first formula is sine of a plus b is equal to sine a cos b plus cos a sin b. And second formula is cos a plus b is equal to cos a into cos b minus sin a into sin b. This formula can be proved using geometry or using coordinate geometry. Okay, so we will use geometry here. Let this is your OX be a ray. Similarly, if I draw another ray OY, and let we draw another ray OZ. Let the angle XOYB is equal to alpha and the angle YOZ be beta. Therefore the angle XOZ will be is equal to alpha plus beta, right? Now let point P be any point lying on the ray OZ. From P, if I draw a perpendicular on the x-axis, it is your PT. From the point P, if I draw a perpendicular on the line ray OY, this is perpendicular drawn on the ray OY from the point P. This is your PR, and from capital R, if I draw a perpendicular on the line PT, it is your Q. Okay. Now if I draw a perpendicular on the R from R on the ray OX, it will be M. So RM is perpendicular to OX. Now your QT is equal to RM. So QT is equal to RM and your QR is equal to TM. So we know as this forms a rectangle, so they must be equal. Now what is sine alpha plus beta? What is sine alpha plus beta? What is sine alpha plus beta? For the triangle POX or POT, your sine alpha plus beta will be is equal to perpendicular by hypotenuse. So it will be is equal to PT by OP. Now your value of PT is equal to PQ plus QT by OP. So if I separate the values, I will get PQ by OP plus QT by OP. Now what is PQ by OP? It doesn't make sense because PQ is side length of another triangle PQR and your OP is the side length of two different triangles, either it is OPT or maybe OPR, both are right angle triangles. Okay, so if I write PQ, see, first of all, this is your angle alpha. So let it be A, this is B and this is A plus B. So for the angle A, this is your capital A and this is 90 minus A, so this must be is equal to capital A. Agar ye wala angle, if it is capital A, then this must be capital A, as it is a 90 degree, so this is your 90 minus A, therefore this angle must be is equal to capital A. Okay, so your PQ is the base for the triangle PQR having angle A and PR acts at the hypotenuse. So if I write PQ by PR into PR by OP. Now for the triangle OPR, it is right angle at the point R. So OP acts as hypotenuse and PR is the perpendicular if the angle B is POR. So PQ by PR into PR by OP. Similarly, what is QT? QT is equal to RM. QT is equal to RM. So if I replace QT by RM, so if I replace QT by RM, what is RM by OR? This is equal to sine A. So if I write QT, if I replace QT by RM and we write by OR into OR by OP. Now OR cancel. This is RM by OP. RM equal to QT. Now what is PQ by PR? Your PQ by PR is equal to cos of A. Now PR by OP is equal to sine B. What is RM by OR? RM by OR is equal to sine A. And what is OR? OR by OP? OR by OP is equal to cos B. So the formula is, it will be equal to sine, sorry, I was calculating for alpha plus beta, but in formula I have taken A plus B. So sine A plus B is equal to sine A cos B plus cos A sine B. So formula is proved. And what about for cos A plus B? For cos A plus B, we know for the triangle OPT, the value of cos A plus B will be is equal to base by hypotenuse. So it must be is equal to OT by OP. Now what is your OT? OT is equal to OM minus MT or TM. You can write OM minus TM by OP. If I separate them, I will get OM by OP minus TM by OP. Now I can write this. What is your OM? OM by OP. OM and OP doesn't make sense because OM is the side of the triangle OMR and OP is the side of the triangle OPR. So if I write OM by OR into OR by OP, now it makes sense, and minus your TM. TM and QR are equivalent. As I know, TM is equal to QR, so I can replace TM by QR, and if I write QR by PR into PR by OP. Now PR gets cancelled, so it will be equal to QR by OP. QR and TM are equal. So what is OM by OR? OM by OR is equal to cos A. OR by OP is equal to cos B from the triangle OPR. Angle R is right angled. Okay, this is B, this is your base, this is your hypotenuse, and QR by PR is equal to sine A, and PR by OP is equal to sine B. So I have proved the formulae of sine A plus B is equal to sine A cos B plus cos A sine B, and cos A plus B is equal to cos A cos B minus sine A sine B. At first, by mistake, I have taken alpha and beta as the angles, but I have corrected. Now the angles are A and B. Now there are two more formulae of compound angles. This is at first sine A minus B. Sine A minus B is equal to sine A cos B minus cos A sine B, and cos A minus B is equal to cos A cos B plus sine A sine B. These two formulae can also be proved or deduced using this geometrical method. I hope you will go through the book of NCERT book or any book that you are following. You will find these proofs. Okay, so this is your sine A minus B and cos A minus B. Using these four formulae, we can deduce all the formulae of multiple angles or submultiple angles of trigonometric functions or trigonometric ratios. In next video, I will deduce the other formula of multiple angles and submultiple angles involving trigonometric functions or trigonometric ratios. Till then, you study these problems and these concepts. If you like my videos, then please like and share my video and do subscribe my channel.